Angular impulse is the momentum. Remember how impulse, the fat equation, the change in impulse equals, or the change in momentum equals impulse, which also equals force times change in time. For now on, we will call it linear impulse, which is change in linear momentum. Don't forget that the F net is the net force acting on the object, and delta t is the time the force acts. Using Newton's second law, we can show an impulse is the change in momentum. F equals ma. And a is just the change in velocity over change in t. So, multiply t on each side, and we get F delta t equals m delta v. Impulse on the left, change in momentum on the right. Change in linear momentum on the right. So rotational impulse is then going to be delta L equals net torque times the change in time. Now that net torque is the net torque acting on the object, and delta t is the time that the net torque acts. Using Newton's second law for rotation, we can show rotational impulse is the change in angular momentum. Remember, so we have torque equals I times alpha. Remember that alpha equals omega, change in omega over the change in time. So we get I times delta omega over delta t, multiply delta t on each side, and we get I times delta omega. Rotational impulse on the left, change in angular momentum on the right. Rotational impulse and momentum theorem appear on the equation chart here. L equals tau times delta t.